Okay, so let's continue. Just now we find that when we are building the decision tree model, it doesn't like those two features. The sales, well, it should be the department of this employee and the salary, low, medium, or high. Okay, so we want to fix those two columns. So you may say, hey, we have already learned two ways, right? One is one hot encoder. We learned that. And the number two, we have also learned label encoder. So there are two ways we can fix them. So why do we want to discuss more? The point I'm trying to make is in the salary column, there are at least three values: low, medium, and high. Okay, so if we want to apply the one hot encoder, what is going to happen? So we are only discussing the salary. Okay, if you are going to do one hot encoder, so eventually you will have a column called uh, salary salary low as one column, and then salary medium and salary high. Okay, so you are converting this column into three columns, and remember we can always drop one. So for example, we can drop the salary high, but in this case you are just taking the low, medium, and high as the color red, green, blue, pink, etc. Okay, so this is not exactly the right thing to do. The point is low is the lowest, and in the middle we have the medium, and the high is the highest value among the three, right? So they should be comparable. This is the point I want to make. Okay, so one hot encoder may not be the cool thing, and the next choice is, well, label encoder, right? So but for the label encoder we have another problem. So for the label encoder, well, it may label the values in a different way. So for example, let me use this one. So if it labels low as a 0, medium as a 1, and then the high as a 2, and that's okay. That's exactly we the way that we understand this is that, because low is the lowest and then medium and high, right? So but if the label encoder did that in the reverse way, so low is 0, medium is 2, and high is 1. And this can be confusing. So we end up with one numerical column. But for this numerical column, medium, which is a 2, medium is greater than high because high is a 1. And this is really confusing. And we don't want that. Why? Because if you go back and see the decision tree, for the decision tree, we take one attribute, for example, the start, and then we are doing a decision. So we are treating this numerical column as really a numerical column. So we want to guarantee that the low means a 0, medium means a 1, and then the high means a 2 in this case. So how do we do that? This is a new way that we can treat the numerical column, and that is we want to do that. We want to create a dictionary. So in this dictionary, I create the low will be mapped to 1, medium will be mapped to 2, and then the high will be mapped to 3. And after that, we want to apply this map to the column salary. Okay, we want to map the low, medium, and high to 1, 2, 3 in the salary column. And this should be the best way that we can deal with the salary column. Okay, so this is the first part. And for the sales, it is just a categorical column, because in the sales we have the sales, we have the marketing, we have the HR, and then you can't say sales is greater than HR. There's no such relationship. So in this case, well, feel free to do a one hot encoder for the sales column. So this is an exercise for you. So number one, you want to apply the one hot encoder to the sales column, and then do the train test split again for the 100% numerical feature space, and after that create the decision tree, and then make the prediction on whether a employee is going to leave or not. So you should pause your video here and then work on your own coding before move on and see my solutions. Okay, so please pause your video now. Okay, so well, I'm going to show you my solution. So well, the sales is the only categorical feature, and then we want to do the get dummies with the drop first as true. So we are dropping one of the column we made, and then if we want to take a look on how many columns do we have and what are they, and you will see for all the different groups or departments that the employee is in, and then they are all here except for one, I believe. Okay, and after that we do the tree and test split again. We make the decision tree, we train the decision tree, we make the prediction, and then we print the classification report and the confusion matrix. So it seems that our decision tree model does a pretty good job in this dataset. So this is a very quick sum up. So a decision tree is just a sequence of if and else rules written in a tree structure. So the cool thing about decision tree is, well, number one, it is the interpretability. So I say it is a white box model, especially if you want to show your decision tree to people with no technical background and at all. They should be able to understand the decision tree. And it can handle both continuous and discrete data in theory. So well, for the scikit-learn, well, we have to do something extra. Well, now so far we have learned 3 ways to deal with the categorical features. Number one hot encoder. Number two, label encoder. And number three, we have to create our own dictionary to map the different values into numbers. Well, and once we build the decision tree, remember the classification is very quick. Well, remember when we talk about the time complexity of the KNN, well, the prediction time of the KNN has the term M, and that M is the number of the training set. So if we have a big training set, and then k nearest neighbor will be very slow because the training set M is large. Okay, however, for the decision tree, once we build the tree, we don't need to use the training samples anymore. So the prediction time of the decision tree is very fast. Okay, so those are all the pros of the decision tree. So what are the problems? What are the risks of the decision tree? And can we fix it? And that will be the topics in the later lectures. So that's it for today, and I will see you guys tomorrow. Bye.